Good morning, class. Geometric constructions are precise methods for drawing geometric figures using only a compass and a straight edge, ruler used as a straight edge, not for measuring. Constructions produce exact results based on geometric principles, unlike freehand sketches, which are approximate. In technical drawing, you must be able to bisect a line, bisect an angle, divide a line into equal parts, and construct perpendiculars and parallels, all without measuring. These are WAEC technical drawing core examination skills. Every construction must be accurate and show all construction lines, light compass arcs, not erased. To bisect a line, find the perpendicular bisector. Problem: bisect line segment AB. Step 1. Open compass to more than half the length of AB, any radius greater than half AB. Step 2. With center A, draw an arc above and below the line. Step 3. With the same radius, with center B, draw arcs above and below the line, intersecting the first arcs. Step 4. Label the intersections above the line as P, and below as Q. Step 5. Draw a straight line through P and Q. Result: line PQ is the perpendicular bisector of AB. It crosses AB at its midpoint M, at exactly 90 degrees. Important: the radius must be the same for both arcs, from A and from B. The arcs must intersect. If they don't, open the compass more. Application: finding the center of a line, constructing a perpendicular at the midpoint, finding the circumcenter of a triangle. To bisect an angle. Problem: bisect angle AOB, vertex at O, raise OA and OB. Step 1. With center O, draw an arc that cuts ray OA at P and ray OB at Q, any convenient radius. Step 2. With center P, draw an arc inside the angle. Step 3. With the same radius, with center Q, draw an arc intersecting the arc from P, label intersection A. Step 4. Draw ray O. Result: ray O bisects angle AOB, angle AOA equals angle ROB equals half of angle AOB. To divide a line AB into n equal parts, without measuring. This uses the parallel line method, Thales theorem. Problem: divide line AB into 5 equal parts. Step 1. Draw a ray AC at any convenient angle from A, not parallel to AB. Step 2. Using dividers or a compass set to any convenient unit, mark off 5 equal distances along AC, label the points A, A2, A3, A4, A5. Step 3. Draw a line from A5 to B. Step 4. Through each point A, A2, A3, A4, draw lines parallel to A5B using set square and T-square until they intersect AB. Result: these parallel lines divide AB into 5 equal parts. Why it works? By Thales intercept theorem, a set of parallel lines cut equal intercept on a transversal. Application in technical drawing. Dividing a space into equal columns or rows. Creating equally spaced holes in a part drawing. Dividing a length that cannot be easily measured, e.g. 73 mm divided by 7 equals 10.43 mm, impossible to measure accurately with a ruler. To construct a line parallel to a given line through a point. Method: use set square and T-square, already studied, or compass and straight edge method. Compass method. Given line PQ and point A above it. Step 1. From A, draw an arc cutting PQ at B. Step 2. With same radius, from B, draw an arc through PQ and above. Step 3. Using dividers, measure arc from P to A, transfer this distance to the arc from B, mark point C. Step 4. Draw line AC. Line AC is parallel to PQ. Constructing a perpendicular from a point on a line. Problem: erect a perpendicular to line AB at point P, which lies on line AB. Method. Step 1. With center P, mark equal distances on either side of P along AB, point C and D. Step 2. Open compass wider, more than PD. From C, draw an arc above the line. Step 3. With same radius, from D, draw another arc intersecting the first arc at E. Step 4. Draw line P. Result: PE is perpendicular to AB at P. Constructing a perpendicular from a point not on a line. Problem: from point P above line AB, draw a perpendicular to AB. Method. Step 1. With center P, draw an arc that cuts AB at 2 points C and D. Step 2. With the same radius from C, draw an arc below the line. Step 3. With same radius from D, draw an arc below the line, intersecting the arc from C at Q. Step 4. Draw line PQ. Result: PQ is perpendicular to AB. The foot of the perpendicular is where PQ crosses AB. Nigerian application: site layouts use perpendiculars to mark out right-angle corners for building foundations. A builder uses a 3-4-5 triangle, the Pythagorean right triangle in practice, which is a field application of geometric perpendicular construction. WAEC Technical Drawing Questions on Constructions. Question 1. Describe the steps to bisect a straight line AB using a compass and straight edge. Answer: 1. With center A, radius greater than half AB, draw arcs above and below AB. 2. With the same radius, center B, draw arcs intersecting the first arcs, labeled P and Q. 3. Draw line PQ. PQ is the perpendicular bisector of AB, crossing it at midpoint M at 90 degrees. Question 2. Describe how to divide a line AB into 7 equal parts without measuring. Answer: 1. Draw ray AC at any angle from A. 2. Mark 7 equal steps along AC, any unit A to A7. 3. Draw line A7B. 4. Through each A, by equals 1 to 6, draw lines parallel to A7B intersecting AB. 5. The 6 intersection points divide AB into 7 equal parts. Question 3. What is the purpose of showing construction arcs on a finished technical drawing? Answer: construction arcs demonstrate the method used to achieve the construction. They show the examiner that the correct geometric technique was applied. Erasing construction arcs and only showing the final line makes it impossible to verify the method. In technical drawing examinations, construction work earns marks. A solution with no visible construction may receive 0 even if the answer looks correct. Question 4. Describe how to erect a perpendicular to a line at a given point on the line. Answer: 1. With center at point P on the line, mark equal distances on both sides of P along the line, call them C and D. 2. With the same radius from C, draw an arc above the line. 3. With same radius from D, draw a second arc intersecting the first at E. 4. Draw line P. This is perpendicular to the line at P. Question 5. Why must the same compass radius be used for both sets of arcs when bisecting a line? Answer: the perpendicular bisector principle depends on finding 2 points equidistant from both endpoints A and B. If the arcs from A and B have different radii, the intersection points P and Q will not be equidistant from both A and B, and the line through them will not bisect AB perpendicularly. Equal radii guarantee that P and Q lie on the perpendicular bisector of AB. Geometric constructions are the pure mathematics of technical drawing. The ability to construct precisely, without measuring, using only a compass and straight edge, is a skill that has been passed from master builders to apprentices for thousands of years. Egyptian pyramid builders, Greek temple architects, and modern Nigerian civil engineers have all used these same principles. Precision is everything. Powered by Lightech Academy academy.lightech.com.ng NERDC-approved SS1 Technical Drawing.